Okay, in this video, we're going to go over how to use a device called a protractor. This is a protractor. And protractors are used a lot in geometry, especially, to measure angles. So you can measure angles like this one here, for example, or in triangles, that sort of thing, or any kind of a polygon. Now I'm going to measure two types of angles. The first type of angle I'm going to measure is what I call an obtuse triangle. Now, or an angle rather. Now remember, obtuse angle basically means that the angle is greater than 90 degrees. And remember, 90 degrees is really just like a squared off portion. All right. Now let's take a look at this protractor, and this is a very common one, and go through some of the elements. You'll notice that it's a half circle, and the half circle goes all the way from 0 to 180 degrees, although it doesn't say 180 there and it doesn't say 0 there, but you get the idea. And you'll notice that on the top, it actually has it reversed from 180 all the way down to 0. Again, now let me show you how to use this. At the bottom of your protractor, there's usually a circle, okay, or a little hole. You take that little hole and you put it right on the vertex of the angle. Remember, the vertex is where the two rays meet. So put it right there at the vertex. Now, once you've got it there, you want to line up, see this line right here? You want to line up that line with one side or one ray of the angle. Now, why do you want to do that? Well, basically, you are lining it up with the 0 portion by doing it that. And so you can actually read the angle measurement going around in that direction. Now, this is confusing for some of my students. Notice that we said this is an obtuse angle, which means we need to be able to read something greater than 90 degrees, right? So when you go up here and see where the arrow is pointing, and if you can, this is what I would strongly suggest, if you can extend that line so that it goes all the way through the protractor, that would probably be very helpful. And I'll show you why here in just a second. So I'm just going to go all the way up there. Not exactly perfect, but close. Now, again, put the hole centered there on the vertex. Make sure that this line is lined up with one side of the rays. Now you'll see that my line extends all the way through the numbers, much easier to read. Since I know this is going to be greater than 90, I'm not going to read the top part, I'm going to read the bottom part. And it looks like it's exactly at 120 degrees. So this angle is at 120 degrees. Okay? Now, let's try this exact same procedure with a different type of protractor and a different angle, okay? So I'm going to use what I called an acute angle, and I'm going to use a protractor that doesn't have a little circle down there at the bottom. So let's talk about that. So remember, we're going to try to identify what kind of angle we have first. And at this particular instance, we have what's called an acute angle. Remember, acute angles have less than 90 degrees. But the process is very, very similar. Instead of putting the hole at the bottom, I'm going to actually just put wherever this little line is at the bottom. And every protractor should have one of those types of lines. And again, you're going to put it right there at the very, very end, and you're going to line up the rest of this angle along one of the rays. Now notice again that my angle doesn't go quite all the way through, and if I want to help myself, I'm going to extend that line. So let me just do that. There we go. Let's put it back down there again. Line up that part, and again you can see that my line extends all the way through. Acute angles, remember, I'm not going to read the top because it's less than 90, so I'm going to read this bottom part here. And notice it's between 50 and 60, and specifically it looks like it's right about 57 degrees because there's 55 right there. Okay, so this angle is 57 degrees. Okay, I hope that was helpful to you.